when we write electron configurations, there's a few terms that are really important, and it's pretty critical that you not confuse them. So I'm going to spend a little time on this video distinguishing between terms like principal energy levels, which is often abbreviated as PELs, compared to sublevels, and then compared to orbitals. They all have distinct definitions. So a principal energy level, there are 7 of them, 7 possibilities, and they're numbers: 1, 2, 3, 4, 5, 6, and 7. Each of those each of those principal energy levels can be split into sublevels, and the sublevels have some slight differences in their energies. So principal energy level 1 in blue here exists with only one sublevel. We call it 1s. Level 2 has 2 sublevels, 2s and 2p. The third level, third principal energy level, has 3 sublevels, 3s, 3p, and 3d. Level 4 has 4 sublevels. They are called 4s, 4p, 4d, and 4f. The same thing will go for 5, 6, and 7, even though we don't have letters that go above f. In theory they exist, but there's no need for them. I do want to point out that within level 2 there are slight energy differences between 2s and 2p. Similarly for 3, 4, 5, 6, and 7, all of the sublevels have slight differences in energy levels. That's how we can distinguish them. Now the word orbital is a little bit different. Within each sublevel, so within 4D, 7p, 2s, there are an odd number of orbitals. And the number of orbitals that's present within each sublevel is based on the type. So all of the s's, 1s, 2s, 3s, 4s, they each contain one orbital. And very often, a little bit later, a couple of videos from now, you'll hear about orbital box diagrams. They are represented by a single box. The p sublevels all contain 3 orbitals, so there's 3 boxes. The d's contain 5 orbitals, and the f's contain 7. Each of the orbitals within a single sublevel, so say inside 3p, there are 3 separate orbitals. Those 3 orbitals are identical to each other in terms of energy, but they are 3 separate regions in space where the electrons are found. So they're equivalent energies. Each orbital can hold up to 2 electrons, which means that your s sublevels with their 1 orbitals can hold up to 2 electrons. The p with the 3 orbitals can hold up to 6 electrons. Each of the d sublevels with 5 orbitals can hold up to 10 electrons, and the f sublevels can hold up to 14 electrons. The next video that'll start up on the link that follows is going to show you how to figure out which sequence these sublevels fall in from lowest to highest energy, and help you figure out how to place the correct number of electrons into each of them and represent them in a couple of possible notations.